I'm Ray Slowick, and I'd like to explain a bit about my master's thesis project. It concerns RFID tag location of slippers, in this case the footwear worn in India. We are attempting to establish a method in which people can identify their own slippers while using an aid to the blind, RFID tags mounted within the slippers themselves. The principle is to use a RFID antenna located at the end of a walking stick or a cane for the blind. Above that we'll have a control panel that holds several feedback devices and several buttons for control. When a person wishes to use the device, they will place the walking stick next to their own slipper as an identifying means and cause the computer chip, we're using Adreno chips inside, to memorize the code from this particular RFID tag. In the future, when they wish to relocate their device, they'll turn on their RFID readers and walk over after coming near the area. They should be able to locate the RFID tag within several feet. In this instance, as indicated by our flashing green light, every time it flashes, I'm getting a new instance of identification. I'm approximately half a meter away from this instance. Directly above, I'm about 8.8 meters away, and off to the side again this way, I'm again 0.6 meters away. If I can turn the cane left to right, I can also locate the device. By sweeping it away slightly, it drops off in frequency. By bringing it in and turning towards it, we gain additional hits with our detector. Obviously, this is a human-in-the-loop device, so the operator will then reduce the range. Right now I'm operating at 21 dB. By reducing the operational strength, signal strength, to 15 dB, I reduce the range. Now my detection range has dropped down to 0.25 meters. From the side it is 0.2 meters. If I reduce my signal strength yet again, I'm able to localize directly to the tag. Now I am less than 10 centimeters away when I get my hit. At this point, it's almost possible to pick up or touch the actual slipper. In this instance, we have other complicating issues. The size and type of tag is important. I have several tags here that are of different shapes and sizes. It may be hard to see if we can light it up. The antenna radiation, the antenna patterns are different with multiple tags. Some use inductive and capacitive elements within them. Others use large ground planes in order to pick up. What has been noted is that with the tag types, the larger the ground plane, the larger the area of the tag, the greater our detection range. This is also true for the antennas and the antenna style. We have three basic antennas to demonstrate. One is a highly localized antenna. This could be used in a future application to place right at the tip of the cane. It would be good only in a very small range, and it gives you direct access to our device, our RFID device. We'll increase our sensitivity again to about 18 dB, and if we bring it in, oh, I think I've lost it now. Oh, there it is. As you can see, with this particular cane tip device, if I move it too far away to either side, I'm dropping. At 18 dB before, I had a much higher strength. Now at 18 dB, it's much more localized. If I simply turn the antenna away, I'm picking up RFIDs from other slippers. The key here would be that the computer that you're using, or the stick that you're using, has to be localized to your particular RFID in your tag. It has to remember it. We are currently working with a prototype that is going to achieve 4 RFIDs. That would give you 2 pairs of slippers that it could find. Larger tuned antenna, the detection range becomes much greater. Rather than a local antenna, this one's tuned. And at our high strength, at 24 dB, we're able to detect from greater than a meter away. We can pick up our tag. So this would give us a much greater amount of distance to work with for our sight impaired individuals. Complications that occur, if we look at this is a walking stick used in India. It's a used device. If you notice, the entire cane is aluminum. By placing the antenna within this, we almost completely negate any radiation patterns. Most of it is absorbed. Likewise, with the single part canes, these also have an aluminum core. In this instance, we've placed the antenna on the outside of the core in order to achieve detection. In the future, we hope to excise a section of the walking stick itself, replacing it with a fiberglass tube that the ends can be then inserted in, and the actual antenna will reside within the tube. Another complicating factor, most of these walking sticks that we've examined from India are breakdown sticks. As can be seen, this would have a very rough effect on antennas. Antennas cabling would have to run inside, be retractable, and may suffer abrasion as they come around the area. These aren't obstacles that cannot be overcome. They can be easily overcome by using a more robust cable and giving a little more lead space inside for it to go. The problem, or the complication, would be you can't get a huge amount of distance then. They would have to have a limited and maybe a safety cable inside to compensate for that effect. Other than that, the project seems to hold great promise. We can localize individual slippers in piles of slippers. The detection angle for the slippers is not critical. We can take a whole pile of slippers, put them up in a random pattern on top of the one that we're hoping to find, and we'll still locate our slipper within it. There it is. It's down there. We can drop again our signal strength, and there it is. So you can still, even with a lot of material around it, you can still find the one that you're looking for with human feedback. The other complications would be if the slippers themselves were on a metal surface rather than on a non-metallic surface. We are experiencing a 30 to 40% reduction in signal strength with the tag on top. In this case, the tag is internal. It's would be held away from a metal surface by about 2 centimeters. If the tag is directly on the metal surface, we can experience up to a 70% reduction in signal strength. These are issues that can be overcome simply by the location of the tag. Likewise, tag location can be achieved by inserting directly into the core of the slipper. In this instance, though, we would have problems with the width, so there may be rebonding issues in that case. Other than that, it seems to be a very good project that holds a lot of promise, and we hope to have more for you shortly.